When you're looking for the center of gravity of a thing, you are really looking for the center of mass. Where do the weights land? Where do the weights act? If you're just looking for the center of a two-dimensional area, like a sheet of paper, you're looking for a centroid. And they use the same method. It's just that center of gravity uses moment equals force times distance. Finding a centroid is the same formula, but we use area instead of force, as we'll see in just a minute. Here's a table out of our book where he's giving us the locations of some centroids of some simple shapes, just to make your life simpler if you need it. You'll recognize this. Here's a rectangle. Its centroid is half the base, half the height, so halfway over, halfway up. Here's a right triangle. Its centroid is 1/3 base, 1/3 height, so it's 1/3 over, 1/3 up, and so forth. Let's look for the centroid of an L-shaped piece of cardboard. Let's say that we're making an art project. We're making a mobile out of this thing, and we want to find out where should we glue on our piece of string so that this shape will perfectly balance, and then we'll add it to our sculpture. So our book has divided this shape into two other shapes. You could divide it another way, but this is what he did. And we'll number those two shapes, 1 and 2. And let's first look for x bar. So where is the overall centroid in the x direction? We'll find the area of shape 1. He tells us that it's 6 inches by 2 inches, so its area must be 12 square inches. Now we're thinking about the x direction, so how far is it to the centroid of shape 1 in the x direction? Well, that's 2 inches wide, so it must be 1 inch over to the centroid. There we are. And what is its moment? The moment of its area. 12 times 1 is 12. Let's look at shape 2, this bottom leg. Its area is 6 inches wide by 2 inches high, so it's got an area of 12 square inches. Where is its centroid in the x direction? If it's 6 inches wide, half that far is 3 inches. It's 3 inches over to its centroid, and its moment is 12 times 3 is 36. Let's add up the moments. 12 plus 36 is 48. Let's add up the areas. 12 plus 12 is 24. Now we'll find the distance. Moment divided by area equals distance. This is just like what we did in the previous set of slides, but instead of using force, we're using area. So moment divided by area equals distance. 48 divided by 24 equals 2. So the distance in the x direction is 2 inches. Now let's look for y bar. Where is the location in the y direction? First, our two shapes, 1 and 2, they haven't changed. They still have the same area, so we can just fill in their areas. But the distance now is going in the y direction. So how far is it to the centroid of shape 1? It is sitting on top of this 2-inch high leg, isn't it? So it's 2 inches up to the bottom of shape 1, and then halfway up shape 1 is another 3 inches, so we have 2 plus 3, we have a distance of 5 inches up to its centroid. And what is its moment? 12 times 5 is 60. Now let's look at shape 2. How far is it in the y direction up to its centroid? It's 2 inches high, so up to the centroid must be 1 inch. And what is its area? Its moment? 12 times 1 is 12. Let's add up the moments. 60 times 12 is 72. Let's add up the areas. Well, they still add up to 24. Now, let's do moment divided by area equals distance. 72 divided by 24 equals 3. So y bar is 3. In other words, the centroid of this thing is 2 inches over and 3 inches up. And so, look, that's right on the edge of that cardboard leg. So we could glue our piece of string right there, and the thing should perfectly balance. Let's look at a different shape, a trapezoid. We can split this into two simple shapes, a rectangle and a triangle, and we'll number those 1 and 2. Let's find the area of shape 1. So we're looking for x bar. Let's find the area of shape 1. And you might remember from geometry class that the area of a right triangle is base times height divided by 2. So 9 times 3 divided by 2 gives us an area of 13.5. What is its distance in the x direction? Well, the centroid of a right triangle is 1/3 over. If the whole thing is 9 inches wide, then 1/3 of that, it's 3 inches over from this square end. That means it's 6 inches over from the point. So the distance from the point on the left end is 6 inches over. Area times distance, 13.5 times 6 is 81. Now let's do shape 2. It's a little more straightforward. Its area is 9 times 3, 27. Its distance in the x direction, what's half of 9? 4.5. So now the moment, 27 times 4.5 is 121.5. Now let's add up the moments. 81 plus 121.5 is 202.5. Let's add up the areas. 13.5 plus 27 is 40.5. Now let's figure out x bar. Let's figure out the distance. Moment divided by area equals distance. 202.5 divided by 40.5 equals 5. So the distance to the centroid in the x direction is 5. Now we'll do y bar, the location in the y direction. Still the same shapes with still the same areas, but let's find the centroid of shape 1 in the y direction. It's sitting on top of a 3-inch rectangle, and then, looking at a right triangle again, its centroid is 1/3 up. If it's a total of 3 inches high, it must be 1 inch up to the centroid. So the centroid for shape 1 is from the bottom up 3 inches and another 1 inch. It's 4 inches up. And its moment, 13.5 times 4 is 54. Now let's do shape 2, the rectangle. How far is it halfway up that rectangle? It's 1.5. Its moment is 27 times 1.5 is 40.5. Let's add up the moments. 54 plus 40.5 is 94.5. Let's add up the areas. There's still 40.5. Now let's figure out the distance. Moment divided by area equals distance. 94.5 divided by, oops, I plugged in the wrong number there. That should be 94.5 divided by 40.5 is 2 1/3. 2 1/3. And I put, don't look at that 101, that's a mistake. I put a bar over the 0.33 because that's a continuing 33333. You don't have to write that bar, but I wanted to. So there's the centroid for that shape. Now let's look at our assignment. And what we have here is the same thing. We have these tables. You'll look up the areas. You'll figure out the distances. You'll find the moments. Then moment divided by area gives overall distance. And you'll do that for x bar and for Y bar. So for this one, you can number whichever shape you want to be 1, 2, and 3, or you can give them some other name if you want. Here's the other shape. There are various ways you could divide this one up. Here are 3 possibilities. There are more. Divide it up however you want. Now, for this assignment, we'll try something different. For this assignment, I have made tables for you in an Excel spreadsheet. So your assignment looks like this. Here's the first problem, and here are the tables in Excel. Now, there are no formulas in here. These are just boxes where you can write text, that's all. So you don't have to worry about any funny calculation stuff. So like I might go shape 1, shape, and I'm typing here with my keyboard, shape 2, shape 3. I'll use this as shape 1. So 2 times 8, the area of that one is 16. If I'm looking for the distance in the x direction, I'll write a 1. Then 16 times 1 is 16, and so forth. This is just, in lieu of having a piece of paper, this is just a way you can fill in some numbers, that's all. There is problem 1 here with a table for x bar and a table for y bar. And then there's problem 2 down below, and you can divide these shapes up however you like. And if you, I forget which one it is, but somewhere you'll get a number that is 1/3, 0.333, or 2/3, 0.666. You do not have to write a bar over those numbers, just write 0.33 or 0.66, if I'm remembering right. Now, you might be okay with these grid lines in here. I rather like them. But if you don't like those, if you want this to look more like a white piece of paper, how can you change the view of this thing? Well, let's look up here at the top. Oh, view! Look there. And it says, stretching out a little bit, do you want to show the grid lines? You can uncheck that box. And look, those grid lines go away, and now you just have what appears to be a white piece of paper. Check that again. So I'm in View, Show, Grid Lines, and the grid lines come back. Do whichever you like. And just fill in the numbers like this were a piece of paper, and save it. File, Save As, and then load it into Moodle. Let me know how that works, and let me know if you have any questions.